Tying the main rebar of columns is a crucial step in the reinforcement process. Workers are meticulously securing the steel reinforcement bars, rebar, using wire ties to ensure they are properly positioned and firmly held together. This precise arrangement is essential for maintaining the structural integrity and load-bearing capacity of the columns, ensuring the building's safety and durability. Shear links, also known as stirrups, are used in column reinforcement to resist shear forces and provide confinement to the core of the column, enhancing its strength and ductility. Purpose of shear links, stirrups, in columns. Shear resistance. Shear links resist shear forces acting on the column, preventing shear failure, which is a brittle type of failure. Confinement. They provide confinement to the core concrete, improving its compressive strength and ductility. Prevent buckling. Shear links prevent the buckling of longitudinal reinforcement bars, especially under high compression loads. Design and placement. Spacing. The spacing of shear links is determined based on the column's design shear force and the diameter of the longitudinal bars. They are typically placed closer at the ends of the column where shear forces are highest. Diameter. The diameter of shear links is chosen based on the design requirements and is usually between 8 mm to 12 mm. Formwork for columns is a crucial aspect of concrete construction, providing the temporary structure necessary to shape and support freshly poured concrete until it gains sufficient strength. The formwork must be designed to withstand the pressure of the wet concrete, ensuring that it maintains the desired shape and alignment. Typically constructed from materials like timber, plywood, steel, or aluminum, column formwork must be robust and well secured to prevent leakage and deformation. Properly designed formwork includes considerations for ease of assembly, disassembly, and reusability, which can significantly affect construction efficiency and cost. Key components include vertical panels or shutters, ties, clamps, and supports such as braces and shores. The interior surface of the formwork should be smooth and treated with a release agent to ensure easy removal without damaging the concrete surface. Adequate planning and precision in the formwork process are essential to achieving high-quality, structurally sound columns. Concreting of larger columns using a concrete pump ensures a continuous and efficient placement of concrete, minimizing delays and maintaining the integrity and uniformity of the structure. Aligning the pump to the pocket in the column formwork ensures precise placement of concrete, reducing the risk of voids and achieving a smooth, consistent pour. Concreting of larger columns with a concrete pump is in progress, ensuring a seamless and efficient process. The concrete pump delivers a continuous flow of concrete directly into the column formwork, maintaining a consistent mix and reducing the likelihood of segregation. The alignment of the pump to the pockets in the formwork is carefully managed to ensure precise placement, which helps in achieving a uniform and strong structure. This method significantly speeds up the construction process, minimizes labor costs, and enhances the quality of the finished columns by reducing potential for air pockets and weak spots. The operation is closely monitored to ensure that the concrete is properly compacted and that the formwork remains stable and secure throughout the pour. The use of formwork external vibrators for compacting concrete in larger columns ensures thorough consolidation, eliminating air pockets and achieving a denser, more durable structure. After pouring and filling the lower level of the column, the concrete pump is aligned to the higher level pocket to continue the concrete placement seamlessly.